Okay, hi, we're gonna be doing mechanical energy. A 78 kilogram object is traveling at a speed of 35 meters per second. What is its kinetic energy? So the equation for kinetic energy is 1/2 times the mass times velocity squared, or the speed. And we know that it has a mass of 78 kilograms, and the speed is 35. Remember to square this one. Okay, and then put in a calculator. So 35 squared times 78 divided by 2, or times 0.5, and you should get kinetic energy of 47,775 joules. Let's do a different color. Next one, a 35 kilogram object has 4,500 joules of potential energy. At what position is the object? Okay, so it gives you potential energy, so you want to use that equation. PE equals mgh. It says the potential energy is 4,500 joules, so you plug that in for PE. The mass is 35 kilograms. And G is a constant, it's gravity, so 9.81 meters per second squared. And then we want to find H. So first we divide these two numbers. Okay, and you should get, you multiply those two numbers. 95 times 9.81. You get 343.35 times H. And now we want to isolate the H, so you divide both sides by 343.35. And that should be your height. So 4,000 divided by 343.35, and your height should be around 13.11 meters. Okay, next one. Any color. Do you like green? Okay. An object is traveling at a rate of 57 meters per second. If its kinetic energy is 123,000 joules, what is its mass? So it says kinetic energy. Oh, it didn't even change. So we want to use the kinetic energy equation. It gives you the kinetic energy, so you plug that in. .5 is the same as 1/2. The mass is what we want to find, and the speed is 57 meters per second. I want to square that. Okay, so do 57 squared, and then divide by 2. You should get, let me write this out, 1,624.5 m, and then to find m, we divide both sides by that number. And the mass should be around 75.72 kilograms. Okay, next one. A different color. Pink. A 98 kilogram object located 37 meters above the ground is moving at a constant rate of speed. If the object's potential energy is 28% of its kinetic energy, what is the object's speed at that point? Okay, so it gives us mass and height. So that means we have to use this, potential energy. We don't know the potential energy, so we're going to find that. The mass is 98 kilograms. G is a constant. And the height is 37 meters. Okay, solve for the potential energy. Multiply that out. 98 times 9.81 times 37. Should get around 35,571.06. Okay, so it says the potential energy is 28% of the kinetic energy. Okay, so that means the kinetic energy is going to be bigger. Okay. So what we're going to do is we're going to divide by 0.28 because the kinetic energy is bigger. Divide by 0.28, you should get 127,039.5. So now we know that is the kinetic energy. But the question is asking for the speed or the velocity. So now we're going to find that. 1/2 mass velocity squared. Okay, and we already know the mass, so we can just find the velocity. The mass is 98 kilograms. I have to find this. Okay, so if you take 127,039.5 and divide it by 98 times 0.5, you should get 2,592.64. Now I find the square root to get rid of the squared. And you should get 50.92 meters per second. Okay, next one. Okay. In a roller coaster, if a car is starting at the beginning of a roller coaster, what is true about the mechanical energy of the system at that point? Okay, so the mechanical energy is always equal to potential energy plus kinetic energy. And if we have a roller coaster, let's really add one. Roller coaster. The beginning, so let's say we're over here. The car isn't moving at all, so then the kinetic energy would be equal to 0. The potential energy would just be whatever. Let's say potential energy is like 500 joules. So the mechanical energy would be equal to 0 plus 500. That means it'd be 500 joules as well. So that means the potential energy and the mechanical energy are equal at the beginning of the roller coaster. So if we look at the options, D will match. Next one. Okay. A 30 kilogram object has a measured potential energy of 45,000 joules. What is the height of the object? Okay, so we have potential energy, so that means we're going to use that equation. The potential energy is 45,000 joules. The mass is 30 kilograms. G is gravity, 9.81 meters per second squared. And we want to find the height. Okay, so what we're going to do is we're going to multiply these two as well. First, 30 times 9.81 is equal to 294.3 times the height. So we want to isolate h, divide both sides by 294.3. And your height should be around 152.91 meters. Next one. Okay. A 60 kilogram object is traveling at a rate of 20 meters per second. If the potential energy is 46% of its kinetic energy, what is the height of the object at that point? Okay, so they give us mass and velocity, or speed, so it means we have to use kinetic energy equation. Let's plug in the values. The mass is 60 kilograms. The velocity is 20. We have to square that. So we do 60 divided by 2, which is 30, times 20 squared. Your kinetic energy should be about 12,000 joules. And we're not done, because it says it wants the height. We can't find the height from kinetic energy, so we have to turn it into potential energy. It says if the object's potential energy is 46% of its kinetic energy, that means that kinetic energy is greater than potential energy. Okay, so that means this time we have to multiply by 0.46 this time. And your potential energy should be 5,520 joules. Okay. Now we want to use this equation to find the height of the object. We found out that the potential energy is 5,520. The mass is 60 kilograms. The gravity is 9.81 meters per second squared. And the velocity is 20. Oh, wait, the height. We want to find the height. So it means we do 60 times 9.81, 588.6. And you should divide both sides by that. You should get 588.6. So then you want to divide by that number to isolate. And your H should be 5,520 divided by 588.6. And so your height should be around 9.38 meters. Okay, next one. Okay, we want to find the velocity at point C. First we're going to do A. So we know that the mechanical energy is equal to potential energy plus kinetic energy. So that means throughout this whole thing, they're all going to have the same mechanical energy. Even as the potential energy and the kinetic energy changes like throughout the thing, the mechanical energy is always going to stay the same. That's going to help us find our answer. Okay, so we're going to find the potential energy at A first. So point A. So the mass is 20 kilograms. The constant is 9.81 meters per second squared. And the height is 80 meters. We're going to multiply that out. So 20 times 9.81 times 80, and you should get 15,696 joules. And we know that up here, the kinetic energy is 0 because the cart is not moving. So that means if the potential energy is 15,696, that means that the mechanical energy throughout the whole ride is 15,696 joules as well. So now we know that the potential energy at C plus the kinetic energy at C will equal this number. Let's find the potential energy at C. The mass is going to stay the same, 20 kilograms. The constant will stay the same, 9.81 meters per second squared. And now the height has changed, it's 50 meters now. I'm going to multiply that out again. And so the potential energy at C is 9,810 joules. We want to find the kinetic energy, so that means we take this number, and subtract to find the kinetic energy. So 15,696 minus 9,810. Now we find the answer. 15,696 minus 9,810. So now we know the kinetic energy is 5,886 joules. Kinetic energy at C. And now the question says they want to find the velocity. So we got to plug it back into the equation. 1/2 mv squared. So the kinetic energy is 5,806. 0.5, mass is 20. We're solving for V. So 20 divided by 2 is 10. And 5,886 divided by 10 is 588.6. Now I want to find the square root. And your velocity should be about 24.26 meters per second. This equals 10, and you divide both sides by 10. Okay. What is the potential energy of an object that is 85 kilograms and is located 12 meters above the ground? So the potential energy, the mass is 85 kilograms. Gravity, 9.81 meters per second squared. And the height is 12 meters. So you just multiply them all together. 85 times 9.81 times 12. And your potential energy should be 10,006.2 joules. So we have a 65 kilogram object traveling at 20 meters per second. If the object's kinetic energy is 42% of its potential energy, what is the object's height at that point? Okay. So it's giving us the mass and the velocity, so we're going to use kinetic energy. Mass is 65 kilograms. The velocity is 20 meters per second. I'm going to square that. 20 squared, 400 times 65 divided by 2. The kinetic energy is 13,000 joules. And it says the kinetic energy is 42% of its potential energy. So that means the potential energy is bigger. You want to convert it to potential energy. So that means in this, we're going to divide by 0.42 to get the potential energy, which is equal to 30,952.38 joules. And we want to find the height. So we're going to plug that in to the equation and solve for h. The mass is 65. No, I'm using this. 9.81 meters per second squared. And the height. So multiply those two together. 65 times 9.81. You should get 637.65. Then you divide this by that number. The height should be around 48.54 meters. Okay, last question. Which of the following violates the law of conservation of energy? So this states that energy cannot be created or destroyed. So we want to have the kinetic energy and the potential energy equal the mechanical energy. Okay, so the mechanical energy is 1,000. 500 plus 500 is 1,000. That's good. The mechanical energy is 500. The kinetic is 298. And the potential is 202. They both add up to 500. The mechanical energy is 20,000. The kinetic is 10,000, and potential is 11,000. When you add that up, you get 21,000. So that means that this doesn't follow the thing. We can keep looking though. Mechanical is 10, kinetic is 2.8, and potential is 7.2. They both add up to 10. That's good. And we already found an option, so it can't be that either. Answer C.